where n times ln of n squared plus 1. Okay, so if you've followed along the series sequentially, you might have done ones that look very similar to this. So from experience, you might think the integral test might be a good idea to try. But let's think about it. Is this integral easy to evaluate? It's probably not. So let's try a different method. And if we really need to, we can go back to the integral test, okay? How about a limit comparison test? So let's say n equals 3 to infinity. The summation of n goes from 3 to infinity, 1 over n times ln of n squared, okay? Well, we pick this series to compare with. So we do the limit comparison test, limit as n goes to infinity, this guy over this guy, okay? So with some algebra, the 1 over n's would cancel, and you're left with ln of n squared on top and ln of n squared plus 1 on the bottom. We get the L'Hopital's rule because it's infinity over infinity. So take the derivative to the top, get this. Derivative to the bottom, get this. The two n's would cancel, and then you get n squared plus 1 on top and the n squared on bottom. This is just algebra. And as n goes to infinity, this is a rational function. Take the ratio of leading coefficients because the degrees are the same. You get what? This is finite and positive. So does this guy converge or diverge? This guy would behave the same. So we got to answer that question now. Does this guy converge or diverge? Well, the reason I picked this is because this we can easily evaluate with the integral test. Okay, so here is the step. So I just said it's finite and positive. Oh, so sorry, positive and decreasing. So this is positive, decreasing, and then I evaluate the integral. Okay, it's infinite. So since this guy diverges, our guy's going to diverge as well by the limit comparison test, okay? If you solve this a different way, I'm sure there's other ways to do this. Please feel free to share in the comments so that other students can learn maybe a more effective method. This is what I thought of right away when I saw this.